Okay. Hello everyone, I am Ms. Suzy from ATAGO. Thank you for joining today's webinar. For people who are watching live, if you have any questions, please feel free to write in the chat box and I will be answering them throughout the webinar. And for people who are not watching on live or for people who have questions after the webinar, please send us an email at overseas@atago.net. So for today's webinar, I'll be talking about urea management, specifically in diesel engine vehicles. So first, I'll be talking briefly about what urea is, and getting into diesel engines, and talk about AdBlue, and introducing our 3 instruments for urea management, and show you some videos about our instrument. So let me start. So first, what is urea used for? So urea is commonly used as fertilizer, mainly in agriculture for vegetables and crops, but also urea is used in diesel cars too. So about diesel car vehicles, diesel engines have a compression ignition system, which they cannot control the oxygen and fuel intake. So the gas that the diesel engine vehicle creates, which is the nitrogen oxide, is very harmful to humans and environment. So to humans, it makes us have difficulties in breathing, causing us headaches, and also lung disease. And for environment, it increases the amount of ozone and also makes us difficult to plant crops. So in the EU, USA, and other countries have regulate nitrogen oxide emissions. So what they do is use AdBlue, which is mainly called in the EU countries, and DEF in USA. So what is AdBlue and why use AdBlue? AdBlue is a diesel exhaust fluid used to reduce harmful gases being released into the atmosphere. So in here, in the brackets, these are the types that are being called, known as the same thing as AdBlue too. So what the AdBlue is made of is 67.5% of water and 32.5% of urea. And what we want to focus is the 32.5% of urea. So if we get the concentration of AdBlue in diesel engines, why don't we measure gasoline concentration of gasoline engines? So gasoline engines use a different ignition system, which is the spark ignition system. Not like diesel engines, the gasoline engines controls the oxygen and fuel intake. So the oxygen that's burnt within the engine is reduced, and so that means that it also reduces the nitrogen oxide emission as well. So for gasoline engines, nitrogen oxide is not a big problem, but more of a CO2 emission problem. So let me talk about what does AdBlue do in diesel engine. So in the diesel engine, when the engine exhausts and creates nitrogen oxide, by mixing the AdBlue in it makes H2O and nitrogen, so it makes water and nitrogen and exhausts in the atmosphere. So this means that there's nothing coming out that is harmful for us and for the environment. This is also known as a selective catalyst reduction, which is the SCR. So why manage urea in AdBlue or DEF? To measure the urea concentration of diesel exhaust fluid, the concentration must be 32.5% of urea, as I said before, in order to work efficiently. So for it to work efficiently is for us to make sure that there's no harmful things going out in the atmosphere. Second is that in increasing urea price have resulted in some diluted AdBlue products being sold in the market. So by managing urea in AdBlue and DEF, you can confirm the concentration with a quick check. So the concentration must be 32.5%, but there are some products that are being sold maybe about 30 or lower. So by managing the urea, not only for the company that's making, but also the one who's purchasing it, they can also check the concentration in order to make sure if it's the correct percentage. So let me introduce our 3 instruments for urea management. The right one is our handheld, and the other 2 is our inline instrument. First, let me talk about our handheld urea management instrument. It's called PAL-urea. It has a range of 0 to 53%. The accuracy is plus minus 0.2, and it has a temperature compensation of 10 to 40 degrees. And as some people may know, we have a lot of PAL series, so it's handheld and you can measure it. You can hold it with one hand and press the button, and that's all that you need. And in our PAL series, we have an NFC function, which you can transfer the measurement data to your phone, or if you have an NFC reader, you can transfer it to your computer too. Next, I would like to talk about our CM-BASEA-urea. So this is our inline instrument. Not like PAL-urea, the range is a bit different. It's from 0 to 50%. The accuracy is plus minus 0.5. The temperature compensation is the same as PAL-urea, which is from 10 to 40 degrees. We have an output of RS232C and DC4 to 20 milliampere, which you can record it analog and in a digital way. And the power supply is DC24V. I will talk about more in detail in the video, but this is it's not a big size, it's a small size, which you can hold it in your hand. Now let me talk about our CM-800-alpha-urea. This is also an inline refractometer, but this is different from the CM-BASEA-alpha because the range is 0 to 55%, and the temperature that you can measure is from minus 15 degrees to 160 degrees, and the accuracy is plus minus 0.3%, and the temperature is also plus minus 1 degrees. And not like the other 2, which is the PAL-urea and CM-BASEA-urea, the temperature compensation is wide from 5 to 100 degrees. The output and the power supplies are the same with CM-BASEA-urea, but with CM-BASEA-urea, you only need one cable, not like the CM-800-alpha-urea. So now let me show you the video of each instrument. But before showing the video, are there any questions? No? Okay, so let me show you the video. So let me start with the measuring PAL-urea. So what you want to do first is make sure to zero set using water. After pressing start, press 0 for zero set. And after it shows 0, press start again to make sure that it shows 0. After it shows 0, now let's do the actual measurement. But before doing the measurement, make sure to wipe the water on the sample stage. You don't want to leave any water because it will change the result. So for the measurement, let's mix the sample, and after mixing it, put some on the sample stage and take several measurements to make sure that the result is stable. The first measurement is 32.5. The second one is 32.5. And the third one is 32.52. So for the cleaning after the measurement, make sure to clean it by water. You don't want to leave any samples, or in this case any ureas, on the sample stage, because if it dries out and it builds in the sample stage, it will affect the measurement. You don't have, if you want to wash it by running water, it is possible too. So now let me introduce our CM-BASEA-urea. As you can see, it is small, and it only has, you only need one cable to connect. If you see the prism stage, there's a dent. And with the CM-BASEa, there's only a 0 button, so it's very easy to use. And for the cable, as I said, you only needed one. So just by using this cable, you can have the power on and output the data too. So now let me introduce our CM-800-alpha-urea. So as you can see, compared to the CM-BASEa-urea, it is bigger and much heavier. You'll be needing both of your hands and carrying it properly. And from the right, you will be needing each cable for the output and the power. And if you see the prism stage, it is flat, not like CM-BASEa-urea. So let me show you the cable. This is the cable for the power. So with the recording output and data output, you'll be needing and buying a cable of your own. Okay, so this is the end of the video. And this is the end of the webinar. Are there any questions for the last minute? Okay, there are no questions. If you have any questions after the webinar, and for people who's watching later, please send us an email at overseas@atago.net. Thank you and have a good day.